So we're going to look at all things related to scripting and automating procedures in Abaqus. So just a few words before that about Intrinsic. We are an engineering consultancy established in 1998. Our main areas of expertise is PLM consultancy and also engineering consultancy. In terms of PLM solutions, we offer the full Dassault range of products such as CATIA, Novia, Simulia, and now the 3D Experience platform. Consultancy-wise, we look into implementation and project management and also software development. We provide support in terms of training and help desk services. From the engineering side, we can take your designs through concept and onto detailed design phase, help you with material and process selections, and with prototype supply and component testing. We have expertise in analysis, structural and thermal, linear, static, or dynamic. We also have various expertise in tool design, styling, jigs and fixtures, and so on. So after these few introductory words, the contents of today's webinar. First, we're going to look at what is the role of scripting within Abaqus CAE. So where can you use scripting and how, and what does it actually do? Then we're going to look into Python, a brief introduction of how the basics of Python works. Also, we're going to look into how can you use scripts for pre-processing and post-processing. And finally, we're going to look at what Abaqus CAE offers you in terms of functionalities to help you develop your scripts. And we'll also look at actual working examples using Abaqus. So what is scripting? Basically, scripts are bits of code that you write in some high-level programming language, and your aim is to automatically perform functions that already exist in your software. So where can you use this? You can automate tasks that you do every day. You can introduce additional functionalities. You can go around some of the issues in the code. You can also, for example, in Abaqus, recover your sessions if they crashed by using the scripts. And I'm sure you can think of a few more other uses of scripting. So basically, where does this tie in? If we look at the Abaqus structure, what we see most of the time is the GUI. So this is Abaqus CAE. However, when we are using the code, so when we click our mouse, what we're basically doing is we are generating lines of Python which will be interpreted and it will be executed according to the kernel. So what we can do is when we are doing pre or post processing, we can use a Python script to automate this process. So the script, what we write, would be interpreted and it would drive the kernel of Abaqus CAE, as opposed to us having clicked through all the activity that we usually do. But else, we can use scripting to get results out of the output database or to even generate additional results. Now, just for the sake of completeness, subroutines are also available in Abaqus. And what we can do with subroutines are meant to expand the capabilities of your solver, so they would actually affect the solution that you get. It can add more functionality into your Abaqus, either standard, explicit, or CFD solver. Also, you can use Fortran or C code to post-process your output database, even without loading up Abaqus CAE or the viewer. So there's more than one way of automating your and pre-processing in Abaqus. But today we're going to look at only Python scripting. So what is Python? So basically Python is a programming language. It has many benefits. For example, it is a cross-platform compatible, so you can use the same code on a Windows, on Linux, on Mac. Also, Python is designed for readability, so once you get used to it and get some experience, you should be able to read these codes much faster than usual generic codes. Also, it's object-oriented. We'll talk about that in a bit more detail later. It is mostly an interpreter language. That means every line as you write will be interpreted as opposed to compiled to machine code and executed that way. It is designed to use less code, so that means lower number of words than most of the usual languages. For example, C++, Java, or some others that you can would normally use. Python is often used for web applications, so it has a strong capability to be used for those type of applications. It is very user-friendly and it's easy to learn. Also, it's supported by a large community. It is free to use, so you can find a lot of tutorials and support and materials online. Last thing probably to keep in mind is Python is strongly typed. That means it makes a difference if you're writing with small or with capital letters. So that is always something to keep in mind, because that's one of the biggest beginner's mistakes that we make. Okay, so where can we use this Python? We can use it basically at three distinct parts of Abaqus. First of all, we can use it to build our models, so we can access existing models, create and modify them. So we can create new ones, we can create geometry, define materials, loads, amplitudes. Basically anything that you can set up in Abaqus CAE, you can set it up using Python. We can also use Python to submit and monitor jobs. We can use it to automate tasks and perform parametric studies. If we have a Python-based optimizer, for example, we can also do optimization type studies using Python. Also, we can use it to post-process. Either we can access the ODB file and extract results, or we can generate new frames or new outputs from existing solved outputs. Also, we can use it to combine steps, frames, and so on. So you see there's a wide range of possibilities that we can do using Python. Now, Abaqus supports both Python 2 and Python 3. There are basically subtle differences. Most of the functions that you're going to use, especially when you're learning scripting, it does not make any difference. However, you can use either to write your scripts for Abaqus. Okay, so let's look a bit more into Python. So basically, Python, although it's object-oriented, it has some standard data types that it is important to understand in order to work with Python. So first, and probably the most important, is numbers. So in Python, there's 4 types of numbers. You can use integers, long integers, float, or complex numbers. As you can see, there's a list of operators that you can use. So addition, subtraction, multiplication, division is probably clear for everybody. Integer division only leaves the integer part. Modulo only leaves the remainder part after division. And power raises the number to a given power. So these are your simplest arithmetic operators that you can use. Now, the second data type, probably a bit more complicated, is a string. So string is basically, you can think about it as a list of characters, but it is immutable. Immutable means you cannot change parts of this string. What you can do is create a new string from the parts of your previous. So for example, we can access individual parts. For example, if I name my string hello world, str, then if I access the first character in the string, I would get back a capital H, because this is the first character, and in Python the numbering starts from 0. Also, I can access just like a section of the string. For example, 1 to 4 would return the characters from the second to the fourth. So in this case, we'll get a ELL. So what if we still want to modify our string? What we can do is we can just redefine the string. So for example, if I want to swap my beginning H for a B, I cannot use just I just cannot refer to the first letter and change it because the string is immutable. What I can do is create a new string that is a combination of a letter B plus all the other letters from the string excluding the first one. So if you understand that, then we are halfway through. Now the second construction is a list. The difference between a list and the string, or we will see a tuple, is a list is mutable. That means you can change the items in it. So for example, if I create my list as a combination of numbers, letters, or even an embedded list, then I can freely change parts of my list, and it would not give me the same error as in the case of a string. But for example, we have to keep it in mind that although we can access an embedded list like this, so the third element, or rather the fourth, because we started counting from 0, so 0, 1, 2, 3 is an embedded list, and then the first element of that embedded list is 0, 1, so that would be Bob. However, we can still not change parts of the string. So for example, if I refer to the first element, so 0, 1, that would be A, B, C, I still cannot change the letter B to an E. I would have to redefine this string as part of my list. What is a tuple? Tuple is an immutable list. So again, I cannot change its individual components. All I can do is I can create a new tuple and name it the exact same way as before, and obviously with new elements. What I can do, however, is I can change the individual list if it's inside the tuple, because that is happening at the list level, not at the tuple level. So for example, this command to change the first element of this list is perfectly valid, although the list inside is inside the tuple. The final standard data type is a dictionary. We can use dictionaries as a lookup table, so we can always give a key and we can give a value. And what we can do is, if we enter the key into the dictionary, we get back the value. Now, it does not have to be a string key and value pair. You can do any combination. So for example, you can input a string, you can get back a number, or the other way around, you can put in a number and you can get back a string. Usually the keys are either numbers or words, but the actual values, they can be anything. So we'll see in Abaqus, lot of your model database, for example, ODB databases are stored in a dictionary, and then what you get back from the dictionary are the actual object models. You can use these various commands, for example, the .keys commands to get a list of all the keys, and you can use the .values commands to get a list of all the values, or you can print out the whole dictionary in the way it's shown here. So these are the basic data types, and then I suppose the next bit to understand is what do we mean by object-oriented. So, for example, in a non-object-oriented code, if we want to deal with different shapes, we'd have to have a large if. So I could look at and say, what if the shape is oval? Then I can tell the code what to do. Otherwise, I can tell, oh, if the shape is a rectangular, then I can tell the code what to do, and so on. However, this is long, it's not clear, it's difficult to change. So what I can do is I can pack basically all my functionalities into objects. So if I create an object, let's say an oval, and I create a getArea method or function inside the shape, then all I have to know is I have to access that shape and call the getArea method, and that would provide me the information based on what's coded inside the object. As you see, for one or two different options, there's not a big difference. However, as soon as you start to expand, so you have like a third shape, for example, you see that it's much easier to encapsulate everything within that object as opposed to keep expanding your if-else tree. And also, objects can take other objects as inputs and can also return objects as their output. So it is a much more convenient and compact way of handling data. It takes some time to get used to it. If you never programmed in an object-oriented language, it might take some time. However, once you get the hang of it, which is fairly easy, then you will see how much you can do with only a few lines of code, and it is really simple. Okay, so where do we find Python in Abaqus? For example, every time you open a session, you would create an replay file, a .rpy file, and this would contain every action that you do inside Abaqus CAE. So when we just double-click on our icon and start Abaqus, these lines of code will get written into the replay file. So basically what happens here is we would import all the necessary commands from Abaqus and from the Abaqus constants library. Then we would create a new viewport. So this is what we see in the CAE. Then we would make this viewport current. We would maximize it. Then we would import all our modules. We'd import utilities for drivers. Then what we're going to do is we would change the part display, so we would be able to see something on the screen. Then we would generate a new model database, and finally we would set the viewport to display nothing at the moment. So as we are familiar with Abaqus CAE, once we run this, these are the commands that we see. So the new model database has been created, and the model1 has been created. So this is basically normally what we see on the screen, but this is all what's happening in the background. Now, just to make some sense of this, so import would get all the commands that you would need to run the Abaqus specific lines in your code. If you just open plain Python, you will not be able to, for example, use the session.viewports because it's not defined. So when you import it from the Abaqus library, then you will have access to all the Abaqus specific commands. Other thing to keep in mind is whenever in Abaqus scripting, a capital letter always refers to creating something. So for example, in this case, session.viewport, it would create a new viewport. And once that new viewport is created, if you want to access it, then we would use a small letter. So as we see here. And here, we can also see the dictionary. So the session.viewport is a repository which is basically a dictionary in Python. So what we can do is we would search using the viewport's name as the key, and we will get back the actual viewport object as the value from the dictionary. Okay, so how can I know how to access data? So Abaqus has object models. So for example, in the models repository, I have a separate model object for every model we create in Abaqus. So by default, this should be model 1. And this model has various fields that I can access. So for example, if I want to create a new material, I would first go to the repository, grab the model I need, and then in that model, I would say I would need the materials. Likewise, in an ODB, so an output database, I could go into the steps, select the step I need, then select the frames I need, and from the specific frame, I can access the field outputs. Now, these are hard to remember, so always refer back to the manual to see what is the object structure within Abaqus. Additionally, and this is tip number 1 that always keep in mind, the easiest way to write scripts is to record them as a macro. So if we click File and Macro Manager, we could create a new macro and then just go through and click through the functionality that at least resembles of what we want to do. So for example, if we want to create a new part, then just start recording the macro, create a new part, any dimensions that we want, it doesn't matter. All what we are interested in is that we will generate some form of script that we can copy paste and then we can adapt it to our use. So by default, you can place the macro in 2 places. Your work directory by default is in the C temp folder on a Windows computer, and your home directory by default is in the C users and under your username folder. So in those folders, you would find the Abaqus macros file, and for any macro that you create, you will see this defined procedure. This is the record of your macro. So for example, in this case, I use this macro to create a steel material model, a linear material model, and also a solid section that uses this steel. So let's look at this macro. What we did automatically with a few clicks is Abaqus generated a list of imports. So these are all the imports that you used to get these functionalities. Now there might be some that you're not actually using. As a recommendation, when you start to work with scripts, you can just copy paste all these and put it in your new script. because it does not hinder your code in terms of execution time to import more. So, but it can help you to avoid problems with not having the correct library imported. So, for example, if you don't import what you need, then you will get back an error message that this, let's say, this method does not exist. So, and then you would think that you've done something wrong in terms of coding, but all you did is just not imported the required library. On the other hand, not all lines are useful. So you can take all the imports, but most of the viewport manipulation lines, you do not need to take them, simply because you're not interested in where you're looking at or how you're looking at the model. All you want to do is you want to generate your materials and sections in this case. Now, if you look at this code, it is fairly self-explanatory that if we create the elastic behavior, we'd have to input a Young's modulus and a Poisson's ratio. Also, we have defined a density. Now, obviously, we can use the same functionality as in Abaqus CAE. So we can define elasticity, for example, as a function of temperature, in which case, instead of just one line, this table can have more than one line, and so on. What I would recommend is, as opposed to going to the manual and looking at exactly how to set it up, it's much faster and easier to just go back to CAE, maybe record a new macro, and then just define a material model with temperature dependence, let's say, with more than one line. Even if the numbers are irrelevant, just to generate the code. And then once you copy the code, you can swap out these numbers to whatever you need. And then it's an easy way to set up your model. So as we see, just by clicking around, we can generate this code in about half a minute. And then we can just grab this and incorporate it as part of our larger script. Okay, so how else can we write scripts? We talked about macro. So macro recording is probably the easiest. Then you can open up a simple text editor, so Notepad, and just start typing. Obviously, this would assume that you already know the syntax, and this is where you can probably make the most mistakes. You have similar functionality in Abaqus, in the PDE, so it's a Python development environment. This would assist you in writing your Python code. So if you're a beginner, this could be a good tool to get used to it and also debug it. And you can use the GUI builder built into Abaqus to create simple dialogues and simple GUI for your functionality. Okay, so this as an introduction to Python. Now we're going to look at how this actually works in Abaqus. So we're going to look at a live demo in Abaqus 2016. I'm going to show you some pre-processing. So I will generate a frame type structure in Abaqus. And also I'm going to show you how to post-process. So I'm going to extract forces, and I'm going to capture some images from my results. So let's just quickly load up Abaqus. Okay, so this is a frame type structure. And this was generated by using a very simple line of code. So I like to use Notepad++. It's a bit more sophisticated than Notepad. It would color the different syntaxes and your comments, and it would make developing code easier. If you like any other text editors, or if you like a specific Python developer environment, that's fine. As long as in the end it will all generate the code and it will all work. So as we see, the beginning of the code is as we discussed. we're going to import all the required libraries. Then what I'm going to do is I'm going to define a set of points as a list of three-dimensional points. So in this case, 1, 2, 3, 4 points are defined. Then I'm going to create a new part. This would also override the previous part 1. So be careful if you're using scripting not to overwrite anything that you still need. And what we can do, as you see, object orientation again. So my points is a list of points. So that means if I use a for loop to loop through all those points, then at every iteration, the point chord variable will be the equivalent of one of the members of this my point list. So at the first step, point chord will be 0, 0, 0. And then in this case, in this part, I will create a datum point at that given coordinate, which is 0, 0, 0. Then I go and I would create another point at 100, 0, 0, and so on. Once I have these points, then what I can do is loop through all these points and connect them with a wire, what I'm going to use later to create a set. So I'm going to use all the wires to create one set. And then on this set, after I define steel material and a profile and a beam cross section, I'm going to apply a beam cross section to all these wires. And in the end, what I'm going to also do is I'm going to turn on the rendering of the beam profiles, so I actually can look at how these beams look. So this is all the code to generate a frame type structure. So if I go to Abaqus, if I look at model 1, so file, run script, and from my list of scripts, I'm going to select the simple frame python.py. This is the file name I give. And when I run it, as you can see, we've created a frame type structure with 1, 2, 3, 4 points and an additional, and there are beams, sorry, there are trusses connecting each of the points. Now, if I decide I need more points, I can go back to the script. I can, let's say, add an additional point. So let's go at minus 50, 80, 25. Doesn't really matter where we put it. I save it. I go back to Abaqus, run the script, and see now we've created an additional point, and that point is connected to all the other points in the frame. Now this is a very simple example. You might want, if you want to create frame structures like these, you would need some logic to guide which points are connected to what, and you can use this same method to set up, for example, lattice for 3D printing or any frame type structure. Now where the points come from, these points could be defined in a text file. You can read it from a generated file. Python can interface many other software, so if there's anything else that would output these points, you can just pick up from those, and as you can see, there's really no limitations what you can do with scripting. Now if we set this model up and set up loads and so on and run it, what we'll end up with is, I already run this, so it wouldn't take us time to set this up. So this is the result by default what we get. Now most of the time for frame structures, what we're interested in is what is the actual force within the beams, so within the trusses. So what we're going to do is write a very simple script to extract the results. Also, just in case you haven't noticed, the default visualization for these beams is not correct, because as these are trusses, I keep saying beams, but these are trusses. That means the force in them should be constant. And as we can see, the default visualization shows you a gradient. So this would have to also be addressed if we want to output results from this. So if we want to post-process this, what we're going to do, see, this code is all that it takes to post-process the results. First of all, we import the ODB access as constants, so we have access to the commands to manipulate the ODB. First of all, we get the first ODB file in the list. Obviously, if you are running a more complicated script or you are having more ODB files open, then accessing the first might not work. But you can also refer to it by name. So, but then this is just a very simple example. Also, what I just mentioned, we have to turn off averaging. So we go in the viewport, we're going to turn off element output averaging. Then what we're going to do is we're going to grab the part. We're going to go to the last frame. So as we see, we'd access the ODB file. Then we'd access the steps repository, which is a dictionary. We'd access or write out all the values from this dictionary. And -1 means we're going to access the last one. So this is the final step. And then, likewise, from the list of frames that are in the final step, we'd access the last frame. So this would mean even if I run a multi-step simulation, I will always find the last frame of the last step. Now my area is just to turn stresses into forces. So that's why I'm going to use 26 square millimeter as my area of the trusses. Again, how I'm going to calculate the numbers. I would access this frame that I just defined. I would access the field outputs, which is also a dictionary, and I'm going to search in this dictionary using S. As we know, if I'm interested in stresses in Abaqus, S stands for stresses. So from this up to this point, I'm going to access all the calculated stress data in the last frame of the last step. And from that data, I'm going to get the subset where the region is my part. So I will get only stresses which are in this truss part. And finally, values would get me the actual values of these stresses. And now this construction on the right side, this is a long list of stress values. And what I'm going to do is, for these values are for every element in my model, and I'm going to use an element to loop through. So I'm going to go through all the elements, and I'm going to print out my element as a text, then the label of the element, and then force, and then the actual stress value times the area and Newton. So if I execute this script, truss output, yes, what I can see is I've created, oh, I actually did it more than once. So I created from 1 to 10 elements, and I've generated the actual forces depending on the loading in these elements. As you can see, we can make the clear distinction whether it's under tension, so the positive, and under compression, so the negative forces. And as you can see, because we changed the display, now we can see that the code did calculate the results correctly. So each truss element has only a single stress and thus a single force value in it. Okay, so this was a simple example how you can post-process frame type structures. Obviously, these numbers can be written to a text file, or you can access an Excel spreadsheet directly, write it into a spreadsheet, and then you could report it, post-process it, and so on. The final script for today, what I'm going to show you, is how can you use scripting to take a picture at the last increment of every step. So for example, you have multiple step analysis and you want to show the different status of the model at the end of different steps. In this script, I use some additional functionality. So I import all the Abaqus functionality, but additionally, I import the date time from Python. So Python has a lot of inbuilt libraries. I'm going to import date time, which let me create timestamps for my files. So I will generate this time string as a year, month, and day format of time string. Then what I'm going to do is I would set up a box, so like an input box, where I would ask, give me some file names, what you want to put into the picture's names. And finally, there's just a simple for loop, as you see here, that would go through all the steps in my model, in my output database. And first of all, I would grab the name of the step for each step what I'm looking at. Then I would grab the viewport name, which I already did. So I would then use set the print options. So I'm going to print a PNG, so a picture. And what I'm going to do is name my file the following way. So I would generate a string which is built up from the model name, which I've input through a text box. Then I'm going to create a string out of the number of the step. Then I'm going to include the name of the step. And then I'm going to include the name of the variable that I'm currently displaying. And finally, I will give it a time stamp. And once I create this title, then I'm going to use the session.print2file command to generate a picture with this name in a PNG format, and I'm going to print out the current viewport that I set. So if we look at how this looks in practice, now this simple frame model has only one step. So I prepared another one, a multi-step, which would have 3 steps defined. And what I'm going to do is I will just run the script. So run print all steps. When I'm going to enter a file name, I could call it Python demo. And what I can see is if I go to my temp folder, so I've created 3 files. Python demo is in the name of every file, then 0, 1, 2 corresponding for 3 steps, then the name of the step, then S because I'm outputting stress, and then the time stamp. And if I open, then I can see, yes, so this is what happens if you don't actually output anything. If you actually turn on, for example, mesostress, Then we can rerun the script. Let's call it again, Python demo. Right, then we'll end up with more pictures, and this time we can actually see the stress values under different loadings that I set up on this frame structure. So last thing to talk about is how can you improve or how can you learn your scripting. There's two main resources that you have to know. First of all, if it's anything Abaqus related, then you can access the scripting and the GUI, both the user's manual and the reference guide. So these are invaluable resources to actually know how to access Abaqus specific parts, how to actually manipulate things inside Abaqus CAE. However, if you're looking at just the Python related, which is what I recommend to begin first, you can look at various online forums, you can look at discussion boards, you can just Google Python tutorials, look at code repositories. There's just so much Python related that you can find online. It's all free, so I would always look for a free solution first before paying anything for Python related material. And you can also go to the official python.org and look at the documentation. So these are where you should get started, and once you are familiar with basics of the language, then you can go and look at how is it actually done in Abaqus. And don't forget that you can always generate your code or parts of the code using the macro recording and then adapt it to your use. So I would like to thank you all for joining to this webinar. I hope you learned something new today and you're going to use scripting in the future, and you can actually get more functionality and more productivity out of the code. If you have any questions, please feel free to ask, and make sure you visit all of our blogs and future webinars where you can also get additional hints and tips regarding Abaqus simulation and CATIA as well. So please, if you have any questions, feel free to ask now. Just type it into the chat. Okay, so it seems it's either all clear or everybody's all confused. If you're still writing your question, please finish it. This can still wait. If not, then thank you very much for attending, and hope you see you back for the next webinar. Thank you.